Hello everyone, my name is Vinay Sawant and today I'm going to present troubleshooting DHCP on Nexus 9000 in NXOS mode in VXLAN Fabric. This was the presentation I gave at Cisco Live 2022 at Las Vegas. This presentation was not recorded when I gave it originally, so I decided to record it in my hotel room. I was one of the speaker at Cisco Live. This was my badge. Mm. And I will go ahead and record it so that it is available to anyone who want to refer it. Again, thank you very much for listening here. Before we start, I would like to give a brief introduction about me. I work with Cisco TAC data center routing and switching team in RTP, North Carolina. I'm working in this team as one of the team leader. I'm working with Cisco TAC since about 9 to 10 years. My day-to-day job at Cisco involves troubleshooting routing and switching problems and related technologies on Nexus 9K, 7K, 6K, 5K, 3K, 2K, and also assist my team members on the escalation calls and various queries they have, plus work with internal team on various questions and developments and improvements related to Nexus product, work in Cisco lab on building customers topology in finding root cause uh, or reproduce the problem in the lab and stuff like that. So this presentation is based on one of the tag case I worked on one of the Sunday shift. So it was a Sunday shift. I was monitoring our queue, and this priority one case came in the bin, and I was available to take this case. So I went ahead and picked up, and I got connected with customer. And after joining the customer's call, I realized there is some kind of urgency going on here, and everybody was like in a panic mode. They were asking a lot of questions, and there's somebody saying, "Hey, is this fixed? How much time it's going to take?" So when I went on call with the customer and I found that network engineer who was troubleshooting this problem was in tremendous pressure, right? So I asked him, "Hey, what are we doing?" And he said, "We migrated from a traditional network to VXLAN based network, and our DHCP is not working after that, and we need to fix this within 1 hour because our production line is going to start in 1 hour, and there is no way we can revert this because we have made a lot of changes and we don't have enough time for that." I said, okay. So I started thinking, right? Whenever we are troubleshooting this problem, we cannot just go and search on Google or some internal documentation on how DSCP is supposed to work, what configuration is required, and how the packet flow happens, right? So that's why it's very important that we know the basics of this feature, how it is configured, and how to verify it's working okay or not. So, so my presentation includes, or I will start with basics of DSCP in a traditional network. Then I will come to how DSCP will work in VXLAN, and then how to troubleshoot a problem. So this is the introduction of the DSCP, then basic problems and symptoms what my customer reported, and collect related data, and then finally the troubleshooting session. So, DSCP basics. The DSCP works in 4 steps. DSCP discover is sent by DSCP client to the DSCP server. Server responds with the offer. The offer comes back to the client. Client now requests a DSCP IP address, and then finally server sends DSCP acknowledgement. All these 4 steps have to happen for DHCP to work properly, and the client to get the IP address. If any one of these steps didn't happen, then the client will not get the IP address. How I remember this is DORA, Dora the Explorer. It helped me remember the sequence and the steps that I have to be troubleshooting and checking when I'm working on DSCP problem. Now, in the next slide, let's go and check uh, what will be the content of every DSCP discover packet and offer packet along the different stages of the path of the packet. So in this picture, you can see that the DHCP client sending a DHCP discover message. The source IP is obviously all zero, destination IP is all 255. Source MAC, the MAC address of DSCP client in VLAN 10, destination MAC is all F. This packet comes to DSCP uh, relay, which is a 9K in the middle, is configured with DSCP relay IP address 10.0.2.2. Now, the relay is going to relay the packet, it's called unicast relay, that broadcast packet back to a DSCP server. So while this packet goes to DSCP server, the source IP is going to be 10.0.1.1 and destination IP is going to be 10.0.2.2. That's the IP address of the DSCP server. Uh, Now the DSCP server is going to send an offer with the source IP address of his own IP 10.0.2.1. Destination IP is 10.0.2.2. That is the IP address of DSCP relay. The packet comes to 9K. 9K is now going to forward that packet back in VLAN 10 source IP address of the DSCP relay and destination IP all 255. Source MAC, the MAC address of the relay, and destination MAC all F. This is how the DSCP offer packet goes back to the client. Client receives it, then the client sends DSCP request, and finally the server sends DSCP acknowledgement. Now, how this process will change if we go into the VXLAN fabric. Let's go and check that on the next slide. In this picture, you can see that DSCP client on the left sends a DSCP packet, source IP all zero, destination IP 255. The packet comes to VTAP 1. VTAP 1 going to encapsulate that DSCP discover packet and it's going to add option 82. Now, what is option 82? Basically, it is information about VRF, information about L2VNI, information about the subnet. It's going to be encoded into the DSCP discover packet as it goes to the DSCP server. I'm going to talk more in detail about DSCP option 82 in the upcoming slides. But for now, just think that VTAP 1 is going to encapsulate the packet and send it over VXLAN fabric. The packet goes to VTAP 2. VTAP 2 is now going to decapsulate it and send it to the DSCP server. DSCP server is now going to send a DSCP offer. The offer will come to VTAP 2. VTAP 2 is going to encapsulate the packet and going to send it back to VTAP 1. VTAP 1 going to decapsulate it and send it back to DSCP client. Now, the process is going to be same for DSCP discover and DHCP acknowledgement. Now that we know how DSCP will packet will flow in a VXLAN fabric, let's think about what are the minimum configurations we need for DSCP to work in VXLAN. There are two minimum configurations. One is configure a unique loopback IP address on each VTAP so that the DSCP response packets or all the DSCP packets goes back to the same VTAP who sent the DSCP discover message. This IP address also act as a gateway IP address for DHCP scope selection. Second option that is needed is enable option 82. The command to do that is IP DHCP relay information option and IP DHCP relay information option VPN. So if these minimum configurations are required for DHCP relay to work or VXLAN, and also remember I have configured IP DHCP relay source interface loopback too. Now that we know what is the minimum configuration that is required, I want to show you the DHCP option 82 content of that packet. DHCP option 82 has a couple of sub options. So sub option 1 is agent circuit ID. You can see here on the top. Agent circuit ID is a fixed value 01080060 plus segment ID 007C9C. Now this segment ID, if you convert to decimal, it comes to 31900, which is the L2 VPN, L2 VNI information, or layer 2 VNI information. Now, it also includes sub option 151. It includes, basically, it is the VRF name or VPN ID. Sub option 11 is a server ID override. So usually this IP address is the IP address of the DHCP server. But in VXLAN environment, we want this IP address to be changed to IP address of DHCP relay agent, because we want all conversation between DHCP client and DHCP server to happen from the DHCP relay. Because if that doesn't happen, there's a chance that packet may get dropped, and we will discuss that in the future in the upcoming slide why it may get dropped. Now, next thing is link selection. Now, link selection is sub option number 5, and this option is used for selecting the proper subnet information, like uh, in this case, you can see 10.190.0.0 is the subnet which is used. So based this information is used by DHCP server to assign IP address from the proper DHCP scope. I will show you how this information is used in DHCP scope policy while we configure a DHCP server. So with that said, we have covered the basics of DHCP. Now let's go ahead and discuss the problem our customer reported. But before that, I have one more slide to show you about how DHCP can be implemented in VXLAN. There are a couple of different deployment options. Option 1, client on tenant VRF-A and server on same tenant VRF-A, but client on VLAN X and server on VLAN Y. Second option can be client on tenant VRF A and server on different tenant VRF B. Third option can be client on tenant VRF A and server on layer 3 default VRF. And the fourth option can be client on tenant VRF A and server on non-default non-VXLAN VRF C. So in this presentation, I'm going to talk about uh, client on tenant VRFA and server on same tenant VRFA, but client on VLAN X and server on VLAN Y. Okay, so now let's get back to the original problem description. What my customer reported, they said our DHCP clients are not getting IP address over DHCP over VXLAN fabric after migrating to VXLAN. So like any problem when we troubleshoot, right? There are there are basic things we need to collect about every problem before we troubleshoot it. Uh, in this kind of problem, you collect information like client MAC address, client VLAN information, location of the DHCP client in VXLAN fabric, L2VNI, VRF information, how the DHCP server is connected to what VTAP, and what is the server IP address. And based on that, you draw your network topology diagram. So in the next slide, let's see how to collect this basic information. You go to the VTAP where the client is connected and run our famous command, show MAC address table address, MAC address, and the VLAN and the VLAN information. In this case, my DHCP client is connected behind VPC port channel 200 in VLAN 1900. I come on VTAP 1 and I do command show run interface VLAN 1900, and I find out that VRF is tenant A, DHCP server IP address is 10.180.101, and if I do show VXLAN, it shows VLAN 1900 is associated with VN segment 31900. Now let's collect the similar information about the server. I do show IP route 10.180.101 VRF tenant A on VTAP 1, and I see that the server is connected via 172.16.0.201. If I go to VTAP 3 and do show run interface loopback 1, I see that that IP address 172.16.0.201 belongs to secondary IP address on VTAP 3. and 4. And if I go to VTEP 3 and I do show IP ARP detail,